You are moving right now, 230 kilometers per second. Not through a city, not through the atmosphere, through the galaxy. You have been moving at 230 kilometers per second since the moment you were born. Your parents were. Every human who ever lived was. Every star you have ever seen in the night sky is moving at that speed or faster. And every single one of us is circling the same thing. Something 26,000 light years away. Something that weighs 4 million times more than our sun. Something we could not photograph until 2022. Something that was already ancient when the first humans looked up at the night sky. You cannot see it. You cannot point to it. You cannot feel it. But it is there. It has always been there. And you have been bound to it since the day you were born. This is Sagittarius, a star, the dark heart of the Milky Way. And by the end of this video, you will understand exactly what it is, what the photograph taken in 2022 actually shows, and why the most disturbing fact about it is not its size, it is the time. For most of human history, nobody knew it existed. People looked at the Milky Way as a band of light across the sky and assumed the center was just more stars. Closer together, brighter. Nothing special. The problem was visibility. Between us and the galactic center, enormous clouds of gas and dust block all optical light completely. When you point a normal telescope toward the constellation Sagittarius, you see nothing. Pure darkness. The center of our own galaxy was invisible. Then in 1974, radio telescopes began scanning the galactic center. Radio waves pass through dust the way X-rays pass through skin, and they found something that had no explanation. A powerful, compact radio source, concentrated into a space far too small for a star cluster, far too bright to be gas, far too stable to be anything we had ever seen before. They named it Sagittarius A star. The asterisk comes from the notation used for excited atomic states in physics. Something energized, something unusual, something massive was there, something invisible, pulling everything toward it. But you cannot see a black hole. You can only see what it does. In the 1990s, 2 teams of astronomers began one of the most patient experiments in the history of science. Keck Observatory in Hawaii, the Very Large Telescope in Chile. Both aimed infrared cameras at the same patch of sky, the galactic center, in wavelengths of light invisible to human eyes. And they began watching individual stars near Sagittarius A star. Not hundreds of stars, a few dozen, year after year, image after image, watching them move. The stars moved fast. Not the slow drift you would expect from distant objects. These stars were whipping around something invisible at speeds that made no physical sense unless something extraordinarily massive was sitting at the center. One star became the key, a blue-white star called S2, completely unremarkable except for where it was and how it moved. S2 orbits Sagittarius A star every 16 years. That is extraordinarily fast for something orbiting the center of a galaxy. Our sun takes 230 million years to complete one orbit. S2 does it in 16. At its closest approach, S2 gets within 17 light hours of the black hole. Neptune is about 4 light hours from our sun. S2 gets that close to a supermassive black hole, and at that distance it accelerates to 3% of the speed of light. 7,000 kilometers per second, fast enough to travel from Earth to the Moon in less than a minute. Scientists tracked S2 for decades. They watched it sweep past the black hole in 2002 and again in 2018. One complete 16-year orbit tracked frame by frame, year by year, as the star accelerated toward periapsis and decelerated away. Then they did the math. To make a star move that fast in an orbit that tight, There has to be something with an incomprehensible amount of mass concentrated in a space smaller than the orbit of Mercury around our sun. The answer was precise: 4 million solar masses. No star cluster could be that dense without collapsing. No gas cloud could hold together under that gravity. No normal object in physics could hide that much mass in that little space. Only one thing fit: a supermassive black hole. Our black hole. The number 4 million solar masses means nothing to the human brain. So let me build the scale from something real. Our sun is 1.4 million kilometers wide. If you drove around it at highway speed, you would not finish the trip in your lifetime. It is so massive that its gravity holds 8 planets in orbit across billions of kilometers of space. Sagittarius A star contains 4 million of them. If you compressed our sun into a black hole, its event horizon would be about 6 kilometers across, smaller than a city. Now do that 4 million times and crush all of it into a single point. The event horizon of Sagittarius A star, the boundary where escape becomes physically impossible, is 24 million kilometers across. Roughly 17 suns laid side by side. Light moving at 300,000 kilometers per second takes 80 seconds to cross that diameter. And the mass is 1.3 trillion Earths. 1,300 billion Earths. Inside that boundary, the word escape stops having a direction. Not because the black hole is made of darkness, because gravity is so extreme that the geometry of space-time itself no longer points toward outside. Every path through space, every trajectory, every possible direction points inward. And deeper still, our equations predict a singularity, a place where the mathematics of physics stops producing meaningful answers, where our understanding of reality runs out of language. But here's the strange part that nobody expected. Sagittarius. A star is quiet. It is not blazing. It is not devouring stars every night. Most of the time it sits there, patient, starved, with its mouth closed. A giant that has spent billions of years barely eating, which makes what was photographed in 2022 even more remarkable. In 2019, the Event Horizon Telescope, a planet-sized network of radio dishes working as a single instrument, released the first photograph ever taken of a black hole, M87 star at the center of a galaxy 55 million light-years away. A glowing ring, a shadow, proof that the mathematics was right. Then, in May 2022, the same collaboration released a second image, this time closer to home: Sagittarius A star. It was harder to photograph than M87 star. M87 star is massive and stable. It changes slowly over days or weeks. Sagittarius A star is smaller and it flickers. Gas swirls around it on timescales of minutes to hours. Brightness shifts constantly. Every time astronomers tried to build a stable image, the source had already changed. They synchronized data from telescopes across the entire planet: Chile, Hawaii, Arizona, Mexico, Spain, the South Pole. Multiple observatories working as one, combining signals, compensating for Earth's rotation, adjusting for atmospheric distortion, building the image pixel by pixel over years of computation. And then they had it. A bright ring of superheated gas, its light bent into a perfect circle by gravity, so extreme that photons complete partial orbits before escaping. And in the center, a shadow. A dark silhouette where light is captured and does not return. 52 microarcseconds across, the equivalent of seeing a donut on the surface of the moon from Earth. For the first time, we saw the face of the thing we had been orbiting our entire lives. Here's the part that stays with you. Sagittarius. A star is 26,000 light-years from Earth, which means every photon that has ever hit our telescopes from Sagittarius A star left that object 26,000 years ago. The photograph released in 2022? That is Sagittarius A star as it existed during the last ice age, when humans lived in small groups around firelight, when writing did not exist, when the first cities were still 10,000 years in the future. Those photons left the galactic center before agriculture, before bronze, before any written word, and they traveled across 26,000 light years of gas and dust and spiral arms and empty space, and finally arrived at our telescopes, and we called it a discovery. But what is Sagittarius A star doing right now in this present moment? We cannot know. Not for 26,000 years. Right now, as you watch this, Sagittarius A star is doing something. Gas is falling in. Stars are accelerating toward periapsis. The event horizon is there. The ring of light is glowing. Something is happening at the center of our galaxy at this exact moment. And the light from that event will not reach Earth until the year 28,026. Whatever Sagittarius A star looks like today, whether it is quiet or flaring, whether a star has crossed the event horizon, or a cloud of gas has triggered a burst, we will not see it for 260 centuries. We are always watching the past. The photograph, the measurements, the orbit of S2, every piece of data we have ever collected. All of it is ancient history, received on a 26,000-year delay we can never close. Light has a speed limit. Information has a speed limit. The present moment of Sagittarius A star is permanently inaccessible. Sagittarius A star does not care about any of this. It is not the most massive black hole in the universe. TON 618 outweighs it by 16,500 times. It is not the farthest, it is not the most active, but it is ours. It was there 4.6 billion years ago when our solar system formed. It was there when the first living cell divided in the early ocean, when the first fish crawled onto land, when the dinosaurs died, when the first human looked up at the night sky and wondered what the band of light across the sky actually was. It will be there long after our sun burns out, long after Earth is gone, long after the last star visible to us tonight has collapsed or drifted away. And the entire time it has been doing exactly one thing: pulling, holding, anchoring. Right now, at 230 kilometers per second, you are orbiting it. You were orbiting it when you were born. You will be orbiting it when you are gone. Your children will orbit it. Every generation that comes after will orbit it. None of them will ever see it as it is, only as it was. The invisible thing at the center of everything. The thing you cannot escape. The dark heart of the Milky Way. Sagittarius, a star. Subscribe if you have not already. And tell me in the comments if you could send one message to whatever exists at the center of our galaxy, knowing it would take 26,000 years to arrive. What would you say?